Alaykum salam. We did not record, though. Alaykum salam. What's your name? Okay, this chapter we are going to discuss computer networks. As I just mentioned, apparently the mic was muted, so I have to go back. In networking technologies, they are very important for our life as human being and for our industries. Some examples of networking technologies are the internet, because it is providing us with real-time communication and global and online communication. There is no boundaries. You can communicate with a country or someone living in another part of the world. Okay. Also, you can have cloud computing. You can access resources from the cloud. There are different type of network models. Okay. And when you want to choose your network model, there are different factors, such as what is the operating system or OS used in your network? How many users do you have? What is the scale of your network administrators and technicians? In our network, we have host devices or end devices, some people call them. End devices or host devices, they are like computers, smartphones. Okay, they have IP address and they request information from the server. When they receive the information back from the server, then they can display it. This information could be, they request a web page. So when they receive it from the server, they will display it. Okay. So the client, they have the software for requesting and displaying the information. Here we have an example client. This is the internet or your network, and this is a server. The other model, as I have just mentioned a few minutes ago, is peer-to-peer network. Each device, they have similar power. Peer meaning they are similar. They are all maybe same configuration. And like A, they can share information with other computers. Same thing, B can share information with others. It depends. Okay. The good thing about this network is cheaper, it's easy to configure, but it is not scalable. Yani this is good for small network, maybe at your home, very small office. Okay. Okay. And they are cheaper, and they don't need they don't need a specific network operating system for them. Okay. And it does not have a centralized communication. You cannot have a centralized authentication. A does not control who will log into B. B does not control who will log on to C. So it has slower performance and poor security. It's not scalable. It does not provide centralized administration. These are all the characteristics of this type of network. Do you have any questions? Okay. Any questions? Okay. In your network, we have different type of devices. So we just mentioned our. Very good. End device. Now we have the intermediary network devices, such as what? Wireless router, LAN switch, router, firewall, multi-layer switch. So what is intermediary network device? Okay. An intermediary device interconnects end devices. For example, like we have just mentioned that access points. It does the management of data as it flows through a network. Okay, intermediary devices. And it connects client and devices together. Okay. It also has the role of an intermediary device, including regenerating or regenerate and transmit data signals, maintain information about what pathways exist in the network. So here my router will decide how my data is going. Okay. Okay, it will control how my data, which path it will go. It will go to the right, to the left. Okay. This is controlled by my router. Okay. It will maintain information about what pathways exist in the network and notify other devices of errors and communication failures. So these are tasks of intermediary network devices. Media types. Media is how is your data traveling. Media could be wire or wireless or space. Okay. The old networks have their legacy cable at the speed of 10 megabits per second. We will show you some examples of these cables, inshallah, later on. And we have nowadays the high-speed fiber cables, which provide speed around 40 gigabits per second. So now with the advances of technology, we have different type of media. We have different type of options. So the type of media types, in general, we have cabled or cables, okay, such as coaxial cable. Coaxial cable uses electrical impulses. So electricity is traveling in this coaxial cables. Or we have twisted pair cables like the one used in our lab. Twisted pair, we'll show you some of these cables. This is a twisted pair here. Here. This is a twisted pair cable. You see here? Twisted pair. And then we have fiber optic cable. This is a fiber optic cable here, and this is its connectors. We have also wireless. Wireless, it uses modulation of specific frequencies and frequencies of electromagnetic waves. That's the Wi-Fi. Okay, so it's using electromagnetic waves. When we talk about network topology, okay, why we need to know the network topologies? Because there are different type of network topologies. Because we have different type of business or industries. We have small organization, and then we have large enterprise with thousands of users. Okay. So the network topology also will be different and will reflect the size and type of your network. We have two major types of network topologies. Physical topology. This describes how the devices are connected. That's why it's called physical. And then we have logical topology. It represents how the data is traveling through from one device to another. This is the logical. How it's running. How is your data traveling? I'm not talking where is the location of this or who is connected to what. I'm talking about mainly your data, how it's traveling. What are the IP addresses? What are your subnets? Okay, so in general, networks are represented through network diagrams. These diagrams are called topologies, network topologies. We have physical topology and we have logical topology. Here we have on the left side a physical topology. Let me maximize this. As you can see here, it illustrates the physical location of your intermediary and cable installations. You can see here, it is mentioned which rack, where is your server room, which floor. On the other hand, logical topology, it illustrates devices, ports, addressing, IP addresses, and subnets on your network. You can see here we are not putting which floor or which room number. We are most concerned about how data is traveling. Please let me know if you have any question. Nowadays, we hear always about internet, intranet, and extranet. So what is the difference between them? We have three main network terminologies that we need to learn about. They are very important. The internet is the mother of all networks. It refers to the services and infrastructure that are publicly available outside of our own network and the supporting infrastructure. Nowadays, the internet is covering the globe. Here, so we have our structure, and we are connected also to services that are available on the public outside our network. The intranet, on the other hand, as you can see here, I like this diagram here. So here we have on the outside, we have the internet, then we have our intranet. Intranet, it means inside, our inside network. So it refers to the network communication within our network. So any services that are provided within an intranet, they are restricted to our network, to our organization, to our campus, to our network. Okay. Access to these services will be controlled through user/device authentication to ensure that they remain private and inaccessible from the internet. That's why it's called intranet. Internal, intranet. Then we have extranet. It allows access to our intranet to outside organizations, but it should be only granted to trusted or authorized organizations or individuals, someone who is helping us, who is providing service to us. This can be temporary, okay, such as business partner or larger customers. Understood? Okay, great. Now you have to make sure that also your networks are scalable. Scalable means scale of network, meaning that it can manage the scale of your network. For the scale of your network, or how big is your network, we can describe your network according to their deployment, how much area they cover, and what type of area that they cover. We have the PAN. PAN is what? Personal area network. We have the LAN, local area network. CAN, campus area network. MAN is metropolitan area network, and then we have wide area network. WAN is for wide area network, very big. Local area network, LAN, it covers a small geographical area, and each device can be classed as being local to each other. So all the computers, they are local, small geographical area, okay? And usually the internal infrastructure for most organizations will normally take the form of LAN. Like our building here, we have one network, okay? Small geographical area, so it's called LAN. It is therefore important to have a good understanding of LAN in order to support it and ensure that the organization can continue to function effectively and efficiently. When you implement your network and choose whether you have LAN or WAN or PAN or CAN, you need to consider the budget, how much it costs, how much money do you have, what skills it needs, what infrastructure do you have existing, what hardware is needed, what is the environment consideration, the number of users, security and network model that you have. For wide area networks, it is covering large geographical area, and it is used to link multiple LANs. We connect different LANs together using WAN. Usually, because WAN is very big and has more complicated than LAN, you will find that part of the infrastructure you have to go through a third party, like your telecom company, maybe. Okay. So that's another. So it's not completely controlled by the organization. Part of it, of the infrastructure, is controlled by third party, maybe like the telecom company. All right. Setting up a broad connection. Now we for a small network, we call it SOHO, small office, home office. What do we need? We need cable, we need DSL connection to the network or to the internet. We need wireless WAN. We need mobile devices, and we need dial-up. These are all can be available on a broadband connection. Okay, some of them are not used, some of them we are using. It depends on what do you have, what infrastructure you have, which area you are living in. So here we talked about setting up a broadband connections for home users. They can utilize these options. For large organizations, enterprises, companies, they can use lease lines. They are more expensive, but they are more professional. Or Metro Ethernet, business DSL, or even satellite. If you are living in a remote area and there is no infrastructure for the telecom company, maybe they will offer you to go through satellite. Network architecture. What is network architecture? It is the technologies that support the infrastructure that moves data across your network. That's called network architecture. What technologies are used? Now we have 4 basic characteristics that the underlying architecture needs to address to meet your expectations. Okay, so you need to consider your fault tolerance. Fault tolerance meaning what? That your network, if one, let's say you have several devices, if one route is fault, at least you can go another route. Okay, that's fault tolerance. And it has to be scalable. We already talked about that. So fault tolerance, scalability. One more thing is the quality of service. Which one has priority? Which traffic has priority? That's quality of service. And security. You have to make sure that your technologies, network infrastructure is secure. These are the 4 factors or characteristics for a reliable network. Fault tolerance, scalability, security, and quality of service. Fault tolerance. Now we'll talk about each one of these. A fault-tolerant network limits the impact of a failure by limiting the number of affected devices. So multiple paths are required for fault tolerance. As you can see here, if this router is damaged or not working, we can go through this way, this path, correct? You can see here, I'm going from here, 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 then I can reach the network. Or I can go here, here, and I can reach this network. So this is fault tolerance. Reliable networks provide redundancy. So fault tolerance is relying on redundancy of your network. So for a reliable network, we implement a packet switched network that's more secure. Packet switch splits traffic into packets that are routed over a network. Each packet could theoretically take a different path to the destination. We are talking about the packet networking. When you study your telecom class, we will study more about the difference between packet switching and circuit switching. So the data is divided into packets, and the packets are then traveling on your network. They could take different paths. Okay. This is not possible with circuit switched network, the old networks. Because it uses established dedicated circuits. About scalability, a scalable network can expand quickly and easily to support network users and applications without impacting the performance of services to existing users. Network designers follow accepted standards and protocols in order to make networks scalable. And I don't want to establish my network, configure my network. Now I have 20 employees, but I know my network after my company after 3 years will have 100 employees. I don't need to scrap all the technologies that I have and then purchase all from the beginning. No, I want to make sure that from the beginning I have a scalable network. So network designers follow accepted standards and protocols in order to make the networks scalable. The quality of service, maybe this is a new terminology for you, or some of you. Voice and live video transmissions require higher expectations for those services being delivered. So if I am having IP telephony in my network, I need to give some priority to the IP telephony. Why? Because when you are talking, you don't want words to be delayed. And you hear two words and then one word is delayed, or it arrives after the third word, and then you don't understand the sentence. Or some part of your network should have more priority than others. Okay. QoS help routers to prioritize network traffic. Data sent includes either a type of service, TOS, or differentiated services. Okay. Serve indicators that allow routers to identify the type of the traffic, the priority of this traffic, and so they need to know the TOS and the def serve of that is added to the data. Is this data high priority or not? The router can tell from what? From these two indicators, TOS and def serve. Without quality of service, we would likely find that we had performance and quality issues and buffering occurring. Buffering meaning that some information is buffered and delayed. Network security, very important. You need to make sure that your network infrastructure is secure. Your information is secure also. So I have to make sure that my network infrastructure is secure. The physical security of your network, where you are keeping your server in a secure place, protected place, cooled place, the temperature is controlled, the humidity is controlled. Okay. And you need to prevent unauthorized access to these devices. We call this network infrastructure security. The information security It's protection of the information of that or data transmitted over the network or stored in the network. Okay. 3 goals of network security, which is, we call them CIA, confidentiality. Only intended recipients can read the data. This is confidentiality. Integrity, it is assurance that the data has not been altered while it's traveling. We call this integrity. And then we have the availability of your network, assurance of timely and reliable access to data for authorized users. So my data is available whenever I need it. Okay, so these are the 3 important characteristics or goals. This is your 3 objectives of your network security. They call them CIA triangle: confidentiality, integrity, and availability. Voice over IP, I've just mentioned now. It requires the support of QoS to operate efficiently in your organization. Buffering and delay would make two-way communication offered by VoIP and teleconferencing impractical. So you have to provide some QoS, high QoS to IP or voice over IP or teleconference or your conferencing devices. Converging network, what's happening? Let me tell you, before we converge networks, what's used to happen is you have in your organization or in your campus, you have one network for your CCTV cameras, one network for fire detectors, smoke detectors, and then another network maybe for telephone. Nowadays, we converged these technologies together, and they are using the same technology. They are all using, for example, IP protocol. So they can use the same cabling. So this is saving on our budget and easier for administrators. So you would have, before the converged network, you will have separate cables for telephone, video, and data. And they will be using different technologies, so you have to hire more technicians. Each of these technologies would use a different set of rules and standards. But nowadays, no, they are using the same standards. Okay. Any questions about this module? I'll have some questions for you. I will, inshallah, will do this after the break. Okay.